The human body is an extraordinary machine, a complex assembly of interconnected systems that work in perfect harmony. Within this marvel of nature lies a hidden universe, a framework of 206 bones known as the skeleton. This intricate scaffolding provides support, allows movement, and safeguards our vital organs. Imagine for a moment a world without bones. We would be shapeless, unable to move or interact with our environment. Our brains, hearts, and lungs would be vulnerable to injury. The skeleton is the unsung hero of our existence, a silent guardian that allows us to navigate the world. From the tips of our fingers to the arches of our feet, each bone plays a crucial role in our daily lives. Some bones are large and sturdy, like the femur in our thigh, designed to bear our weight. Others are small and delicate, like the tiny ossicles in our middle ear, responsible for transmitting sound vibrations. Let's embark on a journey into this hidden universe, exploring the fascinating world of the human skeleton and uncovering the secrets of its 206 remarkable components. The human skeleton is not a random collection of bones but a meticulously organized framework divided into two main parts, the axial skeleton and the appendicular skeleton. The axial skeleton forms the central axis of our body, encompassing the skull, vertebral column, spine, and rib cage. Imagine the axial skeleton as the sturdy mast of a ship, providing stability and support. The appendicular skeleton, on the other hand, consists of the bones of our limbs, arms and legs, shoulders, and pelvis. Think of the appendicular skeleton as the sails and rigging of the ship, enabling movement and interaction with the world around us. This division of labor allows our bodies to function with remarkable efficiency, balancing stability with mobility. Not all bones are created equal. In fact, they come in various shapes and sizes, each perfectly suited for its specific function. Bones are broadly classified into four main types: long, short, flat, and irregular. Long bones, as their name suggests, are longer than they are wide. These bones, such as the femur, humerus, upper arm bone, and tibia, shin bone, act as levers, facilitating movement. Short bones, like those found in our wrists and ankles, provide support and stability while allowing for some degree of movement. Flat bones, like the sternum, breastbone, and scapula, shoulder blade, serve as protective shields for vital organs and provide surfaces for muscle attachment. Lastly, irregular bones, such as the vertebrae and facial bones, have complex shapes that don't fit into the other categories. They often protect delicate structures and provide points of attachment for muscles and ligaments. While providing structural support is a primary function of the skeleton, bones are far from being inert scaffolding. They are living tissues, constantly remodeling themselves throughout our lives. Bones serve as a reservoir for essential minerals like calcium and phosphorus, which are vital for muscle function, nerve transmission, and blood clotting. Deep within certain bones lies the bone marrow, a spongy tissue responsible for producing red blood cells, white blood cells, and platelets. Red blood cells carry oxygen throughout the body, white blood cells fight infections, and platelets help in blood clotting. Bones also play a crucial role in movement. They act as levers, providing points of attachment for muscles. When muscles contract, they pull on bones, creating movement at the joints. In essence, our skeleton provides the framework, and our muscles act as the engine, working in perfect harmony to produce coordinated movement. Section 5, the skull, guardian of thought. Perched atop the vertebral column, the skull is a remarkable structure that houses and protects our most precious organ, the brain. Composed of 22 bones, the skull can be divided into two parts, the cranium and the facial bones. The cranium forms a hard, protective shell around the brain, shielding it from injury. The facial bones give shape to our face and house our sense organs, including our eyes, nose, and ears. The skull also plays a crucial role in speech, with the mandible, or lower jawbone, being the only movable bone in the skull, allowing us to articulate words. Section 6, the spine, our flexible backbone. Running down the back of the body, the spine, also known as the vertebral column, is a marvel of engineering. Composed of 33 individual bones called vertebrae, the spine provides both strength and flexibility. Think of the spine as a series of interlocking blocks, each separated by a disc of cartilage. These discs act as shock absorbers, cushioning the vertebrae during movement. The spine's unique structure allows us to bend forward, backward, and sideways, while also providing a protective channel for the spinal cord. The spinal cord, a vital part of the central nervous system, transmits signals between the brain and the rest of the body. The spine's protective structure helps safeguard this crucial communication pathway. Section 7. The rib cage protecting our vital organs. Encasing the chest cavity, the rib cage acts as a protective barrier for vital organs, including the heart and lungs. Composed of 12 pairs of ribs, the rib cage is a flexible structure that expands and contracts with each breath we take. The ribs are attached to the vertebral column at the back and curve around to connect to the sternum or breastbone at the front. This arrangement creates a secure enclosure, shielding our organs from external forces. The rib cage also plays a crucial role in respiration. As we inhale, the rib cage expands, allowing the lungs to fill with air. During exhalation, the rib cage contracts, forcing air out of the lungs. Section 8. The limbs enabling movement and action. Our limbs, arms and legs are the instruments of our will, enabling us to interact with the world around us. The upper limb, consisting of the humerus, radius and ulna, carpals, metacarpals and phalanges, allows for a wide range of motion, from delicate manipulations to powerful throws. The lower limb, composed of the femur, tibia and fibula, tarsals, metatarsals and phalanges, supports our weight, propels us forward when we walk or run, and provides stability and balance. The bones of our limbs work in concert with an intricate network of muscles, tendons, and ligaments to produce smooth, coordinated movements. Whether we are typing on a keyboard, throwing a ball, or simply taking a step, our limbs are essential for navigating our daily lives. Section 9. Joints, where bones meet and move. Joints are the meeting points between bones, allowing for movement and flexibility. There are various types of joints in the body, each designed for a specific range of motion. Hinge joints, like those found in our elbows and knees, allow for movement in a single plane, like the opening and closing of a door. Ball and socket joints, like those in our hips and shoulders, allow for a wider range of motion, enabling us to rotate our limbs in multiple directions. Gliding joints, found in our wrists and ankles, allow bones to slide over one another, providing flexibility and range of motion. Cartilage, a smooth, slippery tissue, covers the ends of bones at joints, reducing friction and allowing for smooth movement. Ligaments, tough bands of connective tissue, hold bones together at joints, providing stability and preventing dislocation. Section 10. Bone health, a lifelong commitment. Maintaining strong and healthy bones is crucial for overall well-being. Proper nutrition, regular exercise, and avoiding smoking and excessive alcohol consumption are essential for bone health throughout life. Calcium and vitamin D are particularly important for bone health. Calcium is a major building block of bones, while vitamin D helps the body absorb calcium. Weight-bearing exercises such as walking, running, and weightlifting help build bone density and strength. These activities stress the bones, stimulating them to become denser and more resilient. Just as a healthy diet and regular exercise are essential for maintaining a healthy weight and cardiovascular system, they are equally crucial for ensuring the long-term health of our skeletal system. Section 11. A marvel of engineering. The human skeleton is a testament to the elegance and efficiency of nature's design. This intricate framework of 206 bones, each perfectly shaped and positioned, provides support, allows movement, protects our vital organs, and serves as a reservoir for essential minerals. From the delicate bones in our inner ear, responsible for transmitting sound vibrations, to the sturdy femur that bears our weight, each bone plays an indispensable role in our daily lives. Understanding the structure and function of the human skeleton allows us to appreciate the complexity and resilience of our own bodies. Just as astronomers marvel at the vastness and intricacy of the cosmos, we can marvel at the hidden universe within us, a universe that enables us to move, to explore, and to experience the world around us. The human skeleton, a silent guardian, a remarkable feat of engineering, is truly a wonder of nature.